So in neuroplasticity, some of the key points. So just emphasizing neuroplasticity and the adult brain. So the notion that the brain is plastic, changeable organ that continuously grows and changes in response to an individual's environment and experiences. So that was once thought to be restricted to the developmental period. So in adult neurogenesis, the hippocampus can produce 700 neurons per day, the olfactory bulb and striatal neurons, and the effects of experience on the reorganization of the cortex, so reorganization of sensory and motor cortical maps. So, for example, in learning and things like tinnitus and amongst other things as well. So take a moment now to reflect on some of the things that we've sort of talked about around neuroplasticity. What are your thoughts around neuroplasticity? So take a moment. We'll do an exercise to think about, in your own words, in a couple of sentences, what you know to be neuroplasticity. Also, some independent research for yourselves. Identify 3 areas of neuroplasticity research described, we talked about before, and reference it as well. So if you sort of identify 3 areas of neuroplasticity and reference it, and just reinforcing some of the key points. So reflecting some of the studies in the McGuire, Bulletin, and Spires 2006 study, the brains of London taxi drivers, and found a significant higher volume of grey matter in posterior hippocampus in comparison to matched control groups. The hippocampus is associated with spatial and navigational skills in humans and other animals. As part of their training, London cabbies are required, or at least at that point required, to know the knowledge which assesses the recall of the city streets in London and possible routes. It could be that such detailed navigational knowledge altered the structure of London cabbies' brains. So that's the sort of takeaway. The longer they had been in the job, the more pronounced these differences were. A positive correlation was found. Okay, so and on that, what I'd like you to do is sort of think about some of the limitations of the study. What are some of the limitations of that study and some of the findings of that study, the cabby study? So have a moment to think about that. So let's take into consideration the Willett, Glensman, and McGuire 2008 study. The MRI study found that doctors acquired vast sets of knowledge during their careers, did not show enlarged hippocampi compared to IQ matched controls. They could not identify an increase in grey matter volume. Thus, the original effect may be limited to large-scale spatial knowledges. So Weisberg, Newcomb, and Chatterjee 2019 studied a group of 90 young people in MRI study whilst undergoing a naturalistic task, and no correlation was identified between hippocampal volume and their navigational skills. So the conclusion is navigation ability in a typical non-occupation related population does not correlate with variations of hippocampi size. So sensory substitution, neuroplasticity can arise from failure of one of our senses. For example, say someone has loss of vision in blind. So this function can support adaptation to highly complex visual world. So the work of Amidi et al. 2003 into neuroplasticity in the blind suggests that visual cortex may be more modifiable than previously believed by scientists. In an fMRI study of 10 congenitally blind from birth individuals in a verbal memory task and verb generation reading Braille text, they found evidence of reorganization of the occipital lobe. So 2 areas of cortical reorganization identified: interior region of the occipital area, so preference for Braille; posterior region of the occipital area showed preference for verb generation and verbal memory. So maladaptation, so what's known as musician's cramp. So neuroplasticity can become maladaptive. There are specialist areas in the motor cortex for a range of human activities and capacities. These include special areas for each finger. So musicians cramp occurs when the cortical area for one thing extends and overlaps the area for the other fingers. This can result in non-voluntary finger movements such as finger dystonia. This may be caused by excessive practice, which paradoxically may limit a musician's career. So what I'd like you to do is an activity is to sort of have a look and see around research the focal hand dystonia and the musician's cramp, and have a look at some of the suggestions, the research suggestions as possible causes and treatments, and we can sort of feed that back, if you will, please. So one of the things to think about is the neuroplasticity in a stroke. So you've got obviously the hemorrhage, stroke, bleeding in and around the brain caused by a ruptured blood vessel, ischemic stroke, blockage of the blood supply by brain, most common around 85% according to research, a thrombosis plug of blood cells, air, fat, etc. may form, or locally, distally, an embolism. The third is a transient ischemic attack, temporary blockage clearing spontaneously, usually return function, also known as a warning or mini strokes. So the brain damage and consequential processes. The stroke produces a dead or dying area around the blockage or bleed called an infarct. It is surrounded by a poorly functioning area called penumbra or peri-infarct. The Cascade Theory, the process of the brain damage is thought to involve overactivation of blood nutrient-deprived neurons. They produce excessive quantities of glutamate. This in turn activates the MDA synapses of neurons further down the chain. The concentration triggers a sequence of neuronal activity that ultimately destroys them. So neuronal interaction theory, some researchers propose that damage that is remote from the lesion may still disrupt interaction between excitatory and inhibitory neurons in the motor cortex. For example, the study by Grefkees and Think 211. So dynamic neurons and stroke recovery. So post-stroke recovery process is often obviously a lengthy process and may be only partial in leaving residual long-term cognitive motor disabilities. Axonal reorganization and regeneration are central to brain recovery after strokes. This involves sending out axonal and dendrite spouts from the adjacent healthy neurons to repair the disrupted pathways. Although it has been known for a few years that neurons can regrow in limited ways, the process that stimulates recovery was initially unclear. So some informative studies, which I suggest you go away and read, in study of rodent brain infarct, Ueno et al. 2012 found that strokes induces neuronal outgrowth and myelination. Lai et al. 2015, using animal and human models, found evidence that growth and differentiation factor GDF10 is a potential signaling factor. So phantom sensory phenomena, how the phantom limbs occur. So when a body has been amputated, the sensory experience of that limb doesn't always disappear. Individuals continue to experience that missing limb phenomenon known as phantom limb. This can be reflected in their external behavior, for example, swinging the stump of an amputated limb or arm whilst walking. About 50% of amputees experience significant pain according to research from phantom limbs. So Ramachandran and Blakesley, 98, hypothesized that the pain is somewhat somotor sensory cortex. Their study of a patient called Tom revealed that touching his face on the same liposacral side of his face as an amputated arm resulted in sensations from the arm as well as the face. So what I'd like you now as an exercise is to do some independent research on what tinnitus is and how could that be explained in terms of neuroplasticity and possibly phantom sounds. So curious findings, what we're going to do when you have your findings, you're going to contribute and do like a mini presentation discussion with the group. So your explanation should have included links with today's topic, today's lesson, neuroplasticity. Okay, so the task is to sort of, I want you to go away and write down what tinnitus is and how can it be explained in the terms of neuroplasticity and phantom sound. okay? Please. So explaining phantom sound, so subconscious auditory sensation, not accompanied by an external stimulus. It affects about 10-15% of people, 15% of people, according to research, at some time. And there's evidence that it's affected by stress. Cutting the auditory nerve does not eradicate, according to research, in some instances. Therefore, ringing sound is a phantom sound, could be suggested to be a phantom sound in the brain, and often associated with hearing loss linked to cochlear abnormalities, which indicate a cascade neural change in the auditory system. Its treatment has proved somewhat elusive, including relaxation surgery, brain simulation, TMS, and sound therapies to seek and intercept maladaptive neuroplasticity. So memory, brain, and neuroplasticity. So we're going to talk about memory, brain, structure, and neuroplasticity. So memory is distributed rather than modular capacity in the brain and requires collaboration of several areas. There are many different types of memory which are supported by a range of processes and structuring processes. We'll be exploring these in more detail in our next lessons coming up. But the dentate gyrus, a gyrus is a ridge of grey matter on the brain. The dentate gyrus is the form of hippocampal formation. It is thought to contribute towards the formation of new episodic memories. Episodic memories are a long-term memory store that contains details of individuals' past experiences. The hippocampus is a horseshoe-shaped structure located within the temporal lobes adjacent to the amygdala. We have already explored the role of hippocampi in spatial learning and memory, and is believed to have a role in converting short-term memories to long-term memories. It is important in emotional processing, which may be involved in selection memory for retention, for example, flashbulb memories. Amnesia, or memory loss, amnesia may be caused by a range of neural insults, including injury, trauma, brain diseases, infection, neurotoxic substances, for example, excessive alcohol intake. There are two types of memory loss. It is possible to have both at the same time. Retrograde amnesia, depletion of memories prior to neural insult. Tolding, 2002, described the case of Casey, who was unable to remember the past after a motorcycle accident. Interrogate amnesia occurs when people are unable to create new memories after neural insult. The famous case of H.M. Scoville and Milner, 57, as an example. Stroke and memory loss. Approximately 1/3 of people, according to research, who suffer stroke experience memory loss following a stroke is typically linked to neuronal damage. We talked about that in our earlier lessons. Neuroplasticity may have a role in facilitating some memory recovery after stroke. The stroke victims may suffer transient global amnesia, TGA, although this typically recovers spontaneously. Others may experience mild cognitive impairment, and memory problems impact upon daily living. Some may develop more severe memory problems, which are categorized as dementias, vascular dementia arising from ischemic strokes. So now, what I'd like you to do is to sort of take us through as the brain continually changes and reorganizes itself to adapt to its environment. These changes take place across the entire lifespan, from conception to death, and is part of the process known as neuroplasticity. So what I'd like you to think about and sort of write a few paragraphs defining the concept of neuroplasticity, and to discuss examples of neuroplasticity from different stages of the lifespan. You should make reference to scientific research through this discussion. I want you to write down, okay, and make scientific research throughout reference to scientific research. So stages of life in prenatal, postnatal, infant, childhood, adolescent, young adult, early stages of life. Discuss more than one and make clear indication of which lifespan each relates to. So examples of neuroplasticity include any instances which the brain changes in response to environment, for example, learning, parenting, social interaction, traumatic experiences, danger, exposure to TV, smartphone, social media, press, praise, criticism, recovery from illness, injury or exposure to drugs. So make sure you support in your writing your arguments in scientific papers, if you can do that, and mention the methods used by researchers for their main findings. What did they use? What kind of data? For example, fMRI, EEG, what areas of the brain were involved? And please make sure you discuss how neuroplasticity operates in different ways at different stages of lifespan, critically evaluating the included studies. So take some time to do that, please, and we can present that back in future lessons. And sort of what we sort of focus today on is the life experience and brain changes, musician's cramp, brain damage and recovery, stroke recovery, phantom sensory phenomena, according to neuroplasticity.